Welcome back, Mindsetters. We managed to get a hold of the gremlins in the board, so we are back. Tracy almost killed the board, but we managed to stop her. She almost brought out her machine guns and everything, so we managed to stop her and get the board right, because you know how she gets when this board doesn't obey her. I mean, I'm sure her students are also like, yeah, she gets like that with us too, but she doesn't. She's very awesome, and she is ready for you guys. Over to you, Tracy.
Okay, now that my producers decided, he's talking to me now. Anyway, I'm so sorry about that. This board really doesn't like me. I'm sorry. Anyway, moving on. We were busy discussing. We'll go back to being normal. We were discussing the mercury cell. So, besides all the other things, so we said we have NaCl, which goes in. What I was trying to tell you before the board actually had its whole moment was the mercury, okay, is your cathode. So this isn't quite the same reaction as we saw before, because instead of the water reacting with the cathode, we actually have the sodium, which now gains its electron at that cathode and becomes sodium metal. But it forms, remember this is done at very, very high temperatures, it forms what we call an amalgam. So right over here we have a sodium mercury amalgam. And essentially, that is just a very fancy word for a metal mixture. Okay? What happens when you go to the dentist and you need a filling, they put an amalgam in your mouth? It is just a fancy word for a mixture. Okay, but having a sodium mercury mixture really is quite useless for us in the long run. We don't want it. Plus, we all know mercury is a very dangerous metal. It is a heavy metal. We'll talk about why it's so dangerous in a second. It's actually one of my favorite stories. And what happens, it now goes into the amalgam decomposer. At this point, and this is really done through heat, we have H2 gas, which comes off the top. So once again, we still have hydrogen gas coming off. This cell, because it was one of our original cells, is the reason why we say that hydrogen is a byproduct. We put water into the decomposer. We heat it up. It almost looks like a furnace. Hydrogen comes out the top, and sodium hydroxide comes out the bottom. And, let's go back to a pen. And mercury comes out the very, very bottom, which is then put back into the system. So this part over here, you can't really see it. It's a bit hard to see. We have water over here. We have sodium. This is sort of like a mixture here. And we get sodium hydroxide, and then mercury comes out the bottom. So we can actually take all three out. It's slightly different. At this point over here, we have sodium reacting with water, which then gives us sodium hydroxide and hydrogen. Okay? Now, that's a reaction you've most definitely seen before. You had to do that in grade 10 when you looked at the reactivity series. Okay? Now, why would we want to use a mercury cell? We're using mercury, for heaven's sake. Number one, the products are extremely pure. Very, very pure. I know you're sort of going, but hang on, wait, we had an amalgam. We did have an amalgam, but we weren't finished. We're not talking about this product, the amalgam product. We're talking, when I say that the products that come out are very pure, we're talking about those products. Okay, the hydrogen and the sodium hydroxide and the chlorine that comes out the top. Very, very pure. The chlorine doesn't need to be purified against. It's the only thing that comes out the top. It's great. But, and this is a huge but, number one, the mercury is a problem. Mercury can leak out, okay, goes into the environment. Mercury is a heavy metal, okay, and sometimes mercury is also then present in the products, and we're talking particularly in the hydrogen and the sodium hydroxide. That is a huge problem for us, okay? Because now you're going to go, well, why is that a problem? This is one of my favorite stories. I tell my kids this all the time, and maybe Kakleho would know. You've heard the expression mad as a hatter, right?
Yes.
They're not really referring to me, by the way. And most people think, which story do you think it comes from? Where do we have a Mad Hatter?
Alice in Wonderland?
Alice in Wonderland. So most people go, oh, you as mad as a hatter because we're referring to Alice
Yeah.
in Wonderland. Well, actually, we're not.
Really?
Nope, not at all.
So Alice in Wonderland got it from where?
Ah, see, that's what I'm going to tell you. You see,
I
you
know,
can come
I'm
back.
so
You just respond so
smart.
well to it. I know. Anyway, what actually used to happen is hatters was a profession. So you're looking at people who used to make hats and leather goods and that sort of thing. And one of the ways of curing leather is to use mercury on it. We don't do that anymore for obvious reasons. But hatters worked with mercury all the time. Now, mercury isn't one of those toxic metals where you get a little bit in and you automatically, you can notice. It's not. It's what we call a cumulative. So mercury seeps into in through the skin. So it's not like they breathed it in or drank it or anything like that. It's literally just seeped in through the skin. It's also why, please, grade 12s, I know when a mercury thermometer breaks, the first thing you want to do is play with the mercury because it's fun. Don't. Okay? Bad for you. Anyway, moving on. That's my little hint for the day. So, because they were always working with it and it would seep through their hands and they would make hats and shoes and all that sort of thing, but it's accumulative. So, over their lifetimes, it would keep seeping through their hands, through their skin. And it affects the brain and literally makes you go mad. So,
Okay.
hatters,
Were mad after some time.
pretty much, they were insane. They were all just a little wonky,
Oh,
which is why we got the expression,
Mad
you're
as
as
a
mad as a
hatter.
hatter, because hatters were
mad.
mad.
Yeah, but Miguel
Basically.
actually has a question on that.
Yes.
She asks, since Mercury is the oldest and out of phase, why is it that we bother learning about it or writing about it?
Oh, I just love those questions because it's important that you know why we don't use it anymore. There are still places that use the mercury cell, okay? And the whole concept of the amalgam is really important here because that amalgam is your sodium mercury mixture, okay? And yes, we might not use it anymore and it has to have been phased out, but that's a recent thing. The chemistry here is really important. And also, we're trying to put your science in context. If we only showed you the things we use now, you never learn that science is actually about trial and error. And sometimes what we think works today, a year from now, 2 years from now, 10 years from now, we're now going to be going, well, actually, not a good idea. And remember, when we started looking at the mercury cells and when people started using them, we didn't really understand how dangerous things like mercury was. So we are now wiser, hopefully. Maybe we're more environmentally aware, though not always. And we're more conscious of the decisions we're making. So we're trying to put your science into a complete context. I know it feels like a waste, but it's actually a very, very important process. Okay. Hope that helps.
Yes, it does.
Because I know I've got a lot of kids who go, I don't want to know. I know. But
Well, they just think if it causes so much damage and it's just so bad for us, then why don't we just chuck it away and not learn about it and leave it?
money, money, money.
There you go.
That's exactly what it comes down. There are still places in Europe, hopefully
That
not anymore,
use
they're
it.
about to get fined really badly, that we're still using the mercury cell. Money, tradition, family business or business that gets passed down, and that's what you use. And
Yeah.
sometimes, you just don't know any better. So, yeah.
True. So we
Um,
need to know.
I do have a question prepared, but I think there was some coming through. Let's see if we can get through some of those first,
Yes.
and then we'll go into the question I had.
Okay, so there were many questions about how it affects, or the chloralkali industry, how it affects humans and human life. Can you go through that?
Yeah. Guys, that's actually quite important because what I suggest you do is, I've gone through it really, really quickly, is make a table for yourself. So if we go down here, is set up a table and do a couple of things. So you're going to have your membrane cell. Okay, membrane. I've lost the ability to spell. So we have our membrane cell. We have the diaphragm, and then we have the mercury. Okay, and this is where you need to look at similarities and differences between them. So we can make this say advantages and disadvantages. Oh, once again, I've lost this board. advantages, disadvantages. There we go. And now, because I can do this fairly easily, most of them have the same advantages. They produce chlorine, hydrogen, and sodium hydroxide. All three of which is what I ran through really, really quickly right at the beginning, have lots of uses for us. So in terms of how it affects humans, chlorine's used for PVC, disinfectants, purifying water, pool acid, all of that sort of thing. Hydrogen gas, used for the rocket fuel, that sort of thing. Sodium hydroxide used in manufacture of paper, textiles. It's a very, very important industrial base. Those are all the advantages, okay? In terms of human advantages, how does it affect us? Well, a lot of what we use around us is dependent on these things. Remember, chlorine is how we can then be used to make hydrochloric acid. Hydrogen is used to make ammonia, which is then used to make nitric acid, which is then eventually made to use ammonium nitrate, which is then used as a fertilizer. So essentially, hydrogen, this is one of the first stages in making fertilizers. Fertilizers, why fertilizer is important? Because we put them on crops. Those crops grow, they make food, we eat the food, we're happy. Okay? Basic to put it. But we then need to look at, and most of you I think are starting to get there, the environmental impacts. And this is, I'm not going to write it down, but for example, the biggest disadvantage with the mercury cell is the environmental impact, and it uses a lot of energy. Okay, simply, and there you're going back to the production of the electricity, because in the mercury cell, you've got the electricity you need in the actual first part of the cell, then you've got the electricity you need in the decomposer for separating the sodium and the mercury. So not only are you using mercury, which is a very toxic heavy metal, but you're using a lot of electricity, which means if you backtrack it to the production of that electricity, which if we taken it in our context means probably a good chance it's made from coal, extra environmental issues. Be careful here, grade 12s, because what I see is you go, uses lots of electricity, bad for the environment. No, electricity is not bad for the environment. How we produced the electricity is bad. You've got to backtrack it. Be very, very careful. If I got that in a test or an exam, I would not mark that right, because yes, it uses lots of electricity. You can't tell me it uses lots of electricity, bad for the environment. No, it's not. The production of the electricity it uses can be bad for the environment if it's from a coal-fired power station. Be very careful. If it's from a hydroelectric power station, maybe not so much. If it's from a nuclear power station, maybe not so much. Depends on where the electricity comes from. Be very, very careful. Your diaphragm cell also uses quite a bit of electricity, but it's the asbestos. That's bad for the impact when you're talking about impact on humans. Okay? Membrane cell is the best. The membrane is actually an organic polymer. It's very guardedly, it's a close guarded secret. Do not ask me what it is, because I don't know. Okay, no one except the person who produced it and the industry knows what it is. You cannot Google it, you will not find it. Please don't ask, because I don't know. Just going to put it out there, because the answer to that question is, I don't know.
Don't know.
Okay, but it's an organic polymer. That much we do know, which means it's actually not so bad for the environment. Doesn't use as much electricity, which means when we backtrack, it's not so bad. Okay, I'm hoping that helps.
That does. Thank you. And Svesa asked this question earlier. Now Kashifa is also asking it. How do we go about assigning oxidation numbers?
Wow, that's not really part of what we're...
Is it not part of it?
Doing.
Okay.
Sweetie, that's part of redox. And you don't really need to know about the oxidation numbers. And in this section, if you're struggling with that, learn those 3 equations. Okay, it's the only 3 you're going to have to learn them. Okay, the assigning of oxidation numbers is redox. It's not actually part of what we're doing now.
And then there's one here. Let me just... Okay, from the diaphragm cell, is the NaCl from the anode pure?
Anode.
Is it pure?
The NaCl that comes from your diaphragm cell.
From anode is pure.
The anode.
the
that comes out from your cathode, actually. It doesn't come from your anode. You get from here, remember, with the diaphragm cell, that's absolutely disgusting handwriting. Sorry, it does look different when all my handwriting's gone because of my little moment. Okay, remember here we get sodium hydroxide and we get NaCl, which is actually a combination. It's pure once it's refined again. Biggest problem with the diaphragm cells that we have to this product has to go through another process where we get the NaCl out and we get the NaOH. Big problem here, the NaOH isn't a great pure, it's not very concentrated. The NaCl that we do get out then gets saturated again and put into the cell, and we repeat the process, but it's pure once it's been refined, but it's not pure when it comes out to the NaOH.
Okay.
Yeah.
And next, okay, so Bridget asks, what source of energy makes the chloroalkali process practical on a larger scale?
It's electricity. It's an electrical source. It depends on where it's built and what the supply is. It's always practical. Okay, it's a very practical process. It's an easy process, but it's electrical energy that is being transferred into chemical energy. Okay, it is practical. Some of these processes are what we call a batch process. The membrane cell and the diaphragm cell work in what we call batch processes, which means we put in a whole bunch of sodium chloride, let it react, take out the products, and do it again. It's very good for quality control. The diaphragm cell is a continuous process, which means they're just continuously pumping in the NaCl. It's also what uses up so much electricity. But it is practical. It's the energy source is the electricity, and that depends on where it's located, who the energy supply is, which country it's in, all of that sort of stuff. Yeah.
Okay. And then Miguel asks, Miguel is a he. I said she earlier.
Okay.
I'm sorry, Miguel. But he asks, is the function of the membrane to move only positive ions to the cathode?
Yes, it is. That's what makes the membrane so important, is if we go back, which will have nothing on it, remember we put in the sodium chloride, and I don't think you can actually see the blue, so let's do green. I like the green. And that splits up. And what we want is the chlorine ions to be attracted to the anode so they can lose their electrons and form chlorine gas. And we want only the Na plus ions to move across because they are actually attracted to the cathode, which is our negative electrode. And not only is the water, which is then, remember, reduced, which then produces the OH minus ions and the H2 gas, but that means the OH minus and the Na plus can react together. We want that. Remember, with the diaphragm cell, we can have both the positive and negatives traveling, which is why with the diaphragm cell we don't get a pure product, because the Cl minus ions are still attracted to the Na plus ions. They try the difference in the liquid levels is an attempt to stop the Cl minus ions from migrating, and not as many do, but they still migrate because remember, the Na plus ions are attracted to the cathode very, very strongly, but the Cl minus ions are also attracted to the Na plus ions, and they really want to be with them. They like the Na plus ions.
Okay.
Yeah.
Here's another one.
Yeah.
Ashworth asks, does the membrane cell have similar characteristics with an electrolytic cell?
No. Ashworth, this is an yes, sorry, I'm lying to you. It's electrolysis. It is an electrolytic cell. Electrolysis, electrolytic, same thing. Electrolytic cell, electrical energy to chemical energy. We are just looking at a very specific electrolytic cell, which is what happens when I'm using sodium chloride. So yes, the answer is yes.
Yes. Okay. Yes. So let's try find another one for you. Since we are on the ball.
They're doing well tonight,
yes,
grade 12.
They really are. Some of these questions you have already clarified and they now know the answer, but there was one here that
She's trying to find it. There's so many.
There are. Isn't the H2O supposed to have a coefficient of 2?
Okay. When I do the equations. Okay. So it's very possible. let's have a look, because I know you want it, and the answer there is actually no. No, the answer there is 2. You are correct. I apologize. It is actually supposed to be 2. Whoever said that, well done.
Ndamelo.
We have our moments. Sorry, you are correct. If we're writing it as a truly balanced equation, which I wasn't, so yes. Unless, should that be 2 OH? Just trying to check because we've got 2. Yes, it has the coefficient of 2 because we also want 2 electrons. So yes, you are correct.
Okay.
Well done, sweetie.
And then going back to the beginning,
Yes.
someone had asked, what are spectator ions?
Okay, spectator ions are, when you go and let's use the Olympics because it's just finished. We were spectators to the Olympics, okay? I didn't really, not a chance I was ever going to take part. But if you consider all the people who went to sit in the stadiums, they were spectators. They are there because they make the event more enjoyable. They weren't necessary. We didn't need the spectators as per se, but they're nice to have around. When we look at this reaction, the spectator is sodium, okay? And we need the sodium because Cl minus doesn't exist on its own, and OH minus cannot exist on its own, okay? Those are they're negative ions. We cannot find them as just existing on their own. We just happen to be using sodium because we're using sodium chloride, which is brine water. Sodium becomes our spectator. It's not changing phase. It's not changing oxidation number, as one of the girls asked. It's still +1, okay? It's still lost its 1 little electron. Shame the poor thing. But it needs a friend. The negative ions need positive friends. Those are the spectators. So that's why they're there. They don't take part, but they allow the reaction to happen because the negative, or sometimes your spectator is negative, but in this case, a positive spectator allows the negative ions to take part.
Okay.
Yeah.
Do you want one more?
One more, let's go.
Okay, let's go for one more by Dino.
Yes.
Dino asks, so does chlorine gas contribute to air pollution?
If it escapes, absolutely, and it's very dangerous if it does. Chlorine gas, if it escapes from this, is very, very dangerous. In all of these, we've obviously simplified it, and we've shown the gases coming out the top of the cells. They are collected into containers, okay? So they go into storage containers straight away. They don't just allow, they're not allowed to roam free. Chlorine gas is extremely toxic. I spoke about earlier that chlorine gas is the basis of mustard gas. Okay, it is a horrible, horrible, horrible death, okay? It burns, and this is going to be quite disgusting, I'm sorry for our sensitive viewers, it burns your mucous membranes, which is like what the membranes inside your nose and your eyes and your ears. And I actually have an eye infection right now. My eyes are really sore, and it's even worse than that. It's just like when your eyes get all dry and it makes them bleed, and it
that's
is
disgusting.
Chlorine gas. Trust me, you'll know when you've smelt chlorine. I'm sure some of you have smelt hydrochloric acid, or when you put pool acid, too much pool acid in a pool. There's that horrible, and it's pungent. So they know.
And your eyes sting and
they
go
burn
red.
and you want to cough, and it is horrible. So they store it. It's very, very dangerous for the environment.
Okay.
Yeah, very dangerous.
Sure.
Yeah.
I think that's all the questions we have. I think we got through many questions today.
Oh, guys, you did great today. These are very, very good questions. Now, just to quickly wrap up, guys, what you need to do with this is such an important section. I can talk to you about this as much as I like. Make a summary. Make a way of comparing all three. Make sure you know the reactions. Okay, make summaries and comparisons. And I'm actually going to have to say good night.
I think we must.
Thanks, guys. We're going to turn to you to say goodbye.
Thank you, Tracy. Thank you for an awesome show. Thank you, Mindsetters. You guys were also absolutely amazing today. And thank you to Liberty. We will see you next week for another physical science show. Remember to learn more and learn extra. Good night.